This is a video going over section 8.5, and we're going to do a mini lesson on some graphs that will be helpful when we dive into studying hyperbolas next class. Now, if you were in Honors Algebra 2 last year, these graphs will be maybe vaguely familiar. We did them, but that was a while ago, and we, back then, like we will now, just spent a day on them. Okay, so if you want, for one, you can try to answer A through H here, A through M. And so you could pause this and try to do that. And I'm going to walk through it here. Okay, so what kind of symmetry does this graph have, and how do you know? Well, remember the test for even and odd, which helps you with symmetry, is when you plug in negative x to the function. If the result is the exact same function, then this is an even graph, which would have y-axis symmetry. And that's sort of exactly what we have here. If we plug in negative x for x, since the only x out there is squared, we're going to get the exact same function back. So this is an even function, so it will be symmetric across the y-axis. And b goes along with this. It is an even function, yes. Okay. Is the domain of the function all reals? Well, how would I find the domain of something like this? Let's go. I guess I have room to the side a little bit. So anything under a square root, I need, and we're talking about the real numbers here, then I need x squared minus 9 to be greater than or equal to 0. So that is not, there are some values of x for which that is not the case. So the domain is not going to be all reals. So in the next question, let's figure out what it is. Well, if I need x squared minus 9 to be greater than or equal to 0, we're talking about a quadratic inequality. So I'm going to do this difference of squares here, and I'm going to test, and you also can reason this out in your head too, but if I wanted, some people are comfortable doing the actual sign analysis test. Now you'll notice when I put in values greater than 3 or less than negative 3, that's where this product is positive, and in between negative 3 and 3, it's negative. So the domain, since I want greater than or equal to 0, the domain will be negative infinity to negative 3, union 3 to infinity. In terms of the range, well, if I think the smallest coming out of this square root will be, because I'm only taking the, obviously taking the square root of only positive values, so the smallest coming out of this square root will be 0, and it will go towards infinity. So the range is 0 to infinity. Find f of 10 in simplest radical form. Well, f of 10 is going to be the square root of 100 minus 9, so the square root of 91. And about what is the square root of 91? Well, it's in between 9 squared and 10 squared. So maybe we could say about, halfway between, about 9.5. Find f of 100 in simplest radical form. Okay, so f of 100, same idea. 100 squared minus 9, it will be the square root of 9991. And what is that about? I mean, maybe it's pretty close to 100 squared. So I don't know, 99.8, 99.9. As the value of x gets larger and larger, what does that value of f of x get closer and closer to? Well, it's actually getting, if you see what's happening here, it's actually getting closer and closer to the absolute value of x. So notice how f of 100 was super close to 100, and same with f of 10, super close to 10, and the same would be true if I put in negative 10, and same with negative 100 because it's even. So that's why we say the absolute value of x. And then will f of x ever be exactly equal to x? Well, it can't be, because inside the square root, I'm always having x squared minus 9, which is always going to be less than x squared. Same is true for can the value of f of x ever be more than the value of x, and that also can never be the case because x squared minus 9 is always less than x squared. So what does this mean? Well, it means that if I'm looking at this function f of x equaling square root of x squared minus 9, as x gets huge, the value, that y value, gets closer and closer to the absolute value of x. And knowing what we've done this year, what does that mean? It means that the end behavior asymptote of this graph would be y equals the absolute value of x, which is going to help, as you know, with end behavior asymptotes, help guide our graph. So let's use all of this to do a brief sketch. We're going to use the domain and range and the EBA to help us here. So the EBA, I'm going to put that in first, that absolute value graph. And I know that the range is, the domain rather, is negative infinity to negative 3 and 3 to infinity. And it turns out that, as we saw here, that 3 and negative 3, when I put those values in, the output is 0. So those happen to be our x-intercepts. So I've got 3 and negative 3. And as the graph, as x gets bigger, both positively and negatively, it should be going towards that EBA. So we've got a graph that looks like that. So again, the EBA really helps to guide that graph. All right, let's do another here. So I'm going to turn the page here. Say, try to do this second one. It's very similar to the first. Instead of having x squared minus 9, you have x squared minus 1. And the EBA is still going to be y equals the absolute value of x. And then, so my suggestion, it would be to find the domain and range and then graph it. And so you can check out my solutions after you do that. All right, but let's try something that's similar but a little bit different. We've got the square root of, instead of x squared minus something, we had x squared plus. Is this even? Yes, it is still even. When I plug in negative x, I'm getting the square root of negative x squared plus 4, which is just the same as the square root of x plus 4. So definitely even. The domain here, well, remember, inside a square root, I need inside that square root to be greater than or equal to 0. Well, that will always be the case here. So the domain is all reals. The range, you got to be careful here because I can plug in all reals. So I've got the smallest coming out, if I look inside the square root, the smallest x squared would be 0. And then it gets huge. And I've got this plus 4. So inside the square root, it's ranging from 4 to infinity. So what does that mean the range of my function is? Well, it'll be the square root of 4 to infinity or 2 to infinity. And part D, as x gets huge, what simpler function do we think h of x approaches? Well, I'm going to think the exact same because as x gets huge, the plus 4 makes less of a difference. So like in the previous problems, our EBA is going to be y equals the absolute value of x. And again, it's because as x gets huge, that plus 4 is going to make less of a difference. So let's put this together in a graph. I still have the same EBA as the other problems. And the domain is everything, but let's go with when does it achieve the low value of the range of 2? Well, that will happen when x is 0. So that's my y-intercept is 0, 2. And remember, it's an even function, so symmetric across the y-axis, and then it'll get closer and closer. Oops, get closer and closer to the EBA there. Yikes. I mean, it almost looks parabolic here, right? Okay, so that is 3, just a little bit different. All right, let's go to the next page, and some are going to be very similar and some are going to be slightly different. Let's do, maybe I'll do, let's do C, let's do B, I'm debating. Let's let's do C and D together. Okay. C of X. All right. Same process here. Let's think about what the domain is. We can refer back to the first problem because inside the square root is exactly the same. And when we did our sign analysis or just reasoned it out, we found the domain to be negative infinity, -3, union 3 to infinity. Now I should do the range. The range here coming out of this square root would be 0 to infinity, but I'm multiplying by -1/2. So the range will end up being negative infinity to 0. So it's all going to be x-axis or below. In terms of the EBA, we said as x gets huge, this square root of x squared minus 9 will approach the absolute value of x. But we've also got to take into this account this -1/2 outside. So the EBA in this case will be y equals -1/2 the absolute value of x. So let's draw that. So it's just going to be the absolute value graph is flipped over the x-axis and it is vertically smushed. Okay, and we've got these x-intercepts at 3 and -3, and it gets closer and closer to the EBA. All right, let's do something like D now. So when I'm looking at x squared plus, the domain is going to be everything. The range, well, the smallest x squared can be 0. So the smallest this whole square root would be root 36. So the range, to get the range, I'm going to do 2/3 times 6 to infinity, or in other words, the range is 4 to infinity. So the range is 4 to infinity, and that low point of the range occurs when x is 0. In terms of the EBA, well, as x gets huge, the EBA of x squared plus 36 is the absolute value of x, and then I'm going to multiply that by 2/3. So EBA is y equals 2/3 the absolute value of x. So this time we are, so it's a little bit flatter. We're above everything is on or above, the EBA, is above the x-axis. And my low point is at 0.4. Remember this, still having this y-axis symmetry, so getting closer and closer to that EBA. Okay, so try A and B, and the last type I want to, well, let's see. Yeah, let's try, let us try on the next page, the top left, which I'm seeing does not seem to have a, that's okay. I could have numbered it, but we'll just say top left. I didn't number it because the ones that were functions I labeled as functions. Okay, and this one is not a function. So this is different. So unlike the others where it was f of x or g of x, or in other words, y equals something, well, I've got y squared. So let's solve for y. Y squared equals x squared plus 25. And I'm bringing the x squared to the other side. If I solve for y, I've got y equals plus or minus the square root of x squared plus 25. Definitely not a function. But let's figure out what this looks like. We already did something very squared to, I'm trying to see if, looking back, if we did, I don't think we did x squared plus 25. We did x squared plus 36. We did x squared plus 4, so super similar. So there's two EBAs here. They're going to be plus or minus the absolute value of x. So let's do the positive absolute value and the negative. And no x-intercepts here. The domain is everything. The range of the plus square root of x squared plus 25 is 5 to infinity. And the range of the negative square root of x squared plus 25 will be negative infinity to negative 5. So it'll look something like this, which is kind of neat. Very similar to what we did in previous problems, but now I have both above the x-axis and below the x-axis. So I invite you to try this next one here, which is going to be slightly different. And let's look at something like f of x, and then I'll have you try g of x. So f of x, instead of just x squared, we've got inside the square root completed square form. So what does this mean? Well, first of all, we can reason out the domain here. The domain, because the x is squared and plus something, if I think about x minus 5 squared plus 9 greater than or equal to 0, well, that's always the case. So the domain here is all reals. The lowest point of the range will be when x minus 5 squared is 0. So we can think about the range being 2 times the square root of 9 to infinity, or 2 times 3 to infinity. So the range here will be then 6 to infinity. In terms of the EBA, so same idea as before, but notice not only x is squared. So the EBA isn't just coming out of the square root part, isn't just going to be the absolute value of x. In this case, the EBA is going to be coming out of just the square root piece, would be the absolute value of x minus 5. And then I'm going to multiply it by 2. So my EBA is y equals 2 times the absolute value of x minus 5. Think of the absolute value graph shifted to the right 5. And in this case, also vertically stretched by a factor of 2. So let's go 5 to the right. 1, 2, 3, 4, 5. And again, just drawing a rough sketch here for f of x. And the low point is going to occur at 5, 6. So I'm going to go up 6. So this point will be 5, 6. And there's your sketch for f of x. So when you look ahead to do g of x, the first step will be to get it into this completed square form. I know completing the square never seems to go away. So now's the time to get good at it. So put it in completed square form, and then it will be very similar to f of x. Okay, good luck.